Good morning, everyone. My name is Iraniel Kasuga, and today we're going to discuss the historical overview of the development of mathematics in medieval and Renaissance period. Now let's start first to the development of mathematics in medieval period. Medieval mathematics from the 4th to the 5th centuries, the early Middle Ages or Dark Ages, period of stagnation and spreading the knowledge from the east. Much mathematics and astronomy available in the 12th century was written in Arabic. The Europeans learned Arabic. By the end of the 12th century, the best mathematics was done in Christian Italy. During the, during the century, there was a separate translations of Arabic works to Latin. Later, there were other translations such as Arabic to Spanish Arabic, Spanish Arabic to Hebrew or Latin, and Latin to Greek, and Greek to Latin. Also in this period, Europe had fallen into the Dark Ages, in which science, mathematics, and almost all intellectual endeavor stagnated. Scholastic scholars only valued studies in the humanities, such as philosophy and literature, and spent much of their energies quarreling over subtle subjects in metaphysics and theology, such as how many angels can stand on the point of a needle. That was the questions that was focused back then on the Dark Ages. Now let's proceed to the philosophers and mathematicians in medieval period. We have first Boethius, which is the most influential and early medieval philosopher, and his famous works are the Consolation of Philosophy that was widely translated and reproduced secular work from the 8th centuries until the end of Middle Ages. Now let's discuss his quadrivium. Quadrivium is the four subjects or arts, namely arithmetic, geometry, music, and astronomy. The word is Latin meaning four ways and is used for the four subject that has been attributed to Boethius or Cassiodorus in the 6th century. Here are the summary of the quadrivium subjects, which are arithmetic, geometry, music, and astronomy. Now let's proceed to Nicomachus of Greece. Nicomachus of Greece was an important Asian mathematician best known for his introduction to arithmetic and manual of harmonics in Greek. He was born in the Roman province of Syria and was strongly influenced by Aristotle. He was a Pythagorean who wrote about the mystical properties of numbers. Under Nicomachus' Introduction to Arithmetic, here's the definition of arithmetic sequence. An arithmetic progression AP or arithmetic sequence is a sequence of numbers such that the difference between the consecutive term is constant. Here is the formula for the arithmetic sequence, which is a of n is equals to a of 1 plus n minus 1 times d, where a of n is the ninth term, and a of 1 is the first term, and n is the rank or order of the term, and d is the common difference. To sum up, this is the formula in getting the ninth term. We also have Leonardo of Pisa, or also known as Fibonacci, who's Europe's first great medieval mathematician and introduced Hindu-Arabic numerals to Europe in his work Liber Abaci, which also popularized the Fibonacci sequence and methods for solving algebraic equations. Amen. Leonardo of Pisa, or Leonardo Pisano, is better known for his nickname Fibonacci. Fibonacci was an Italian mathematician from the Republic of Pisa, considered to be the most talented Western mathematicians of the Middle Ages. The name he is commonly called, Fibonacci, was made up by 1838 by the Franco-Italian historian Guillaume Libri and is short for Fiulus Bonacci. 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 Here is the definition of Fibonacci sequence, which is a sequence which each number is the sum of preceding ones. Numbers that are part of the Fibonacci sequence are also known as Fibonacci numbers, denoted as f of n. Fibonacci sequence was the solution of a rabbit population puzzle in Liber Abaci. In Liber Abaci, Leonardo considers a hypothetical situations where there is a pair of rabbits put in the field. They mate at the end of the month of one month, and by the end of the second month, the female produces another pair. The rabbit never die, mate exactly after a month, and the females always produce a pair, one male, one female. The puzzle that Fibonacci posed was, how many pair will there be in 1 year? If one calculates, then one will find that the number of pairs at the end of the ninth month will be f of n, or the ninth Fibonacci numbers. Thus, the number of rabbit pairs after 12 months would be f of 12, or 144. Here is the Fibonacci sequence formula, where f of n is equals to f of n minus 1 plus f of n minus 2, such that for n is greater than 2. Now let's proceed to Nicole Erasme. Nicole Erasme used a system of rectangular coordinates and developed the first proof of divergence of the harmonic series. Nicole Erasme, also known as Nicolas Erasme, is a significant philosopher of the later Middle Ages. Erasme determined opponent of astrology, which he attacked on religious and scientific grounds. Erasme first examined raising rational numbers to rational powers before extending his work to include irrational power. Significantly, Erasme developed the first proof of divergence of the harmonic series, and his proof, requiring less advanced mathematics than current standard tests for divergence, begins by noting that for n is the power of 2, and there is n over n minus 2 terms in the series between 1 over n over 2 and 1 over n. Now, to sum up, this is the harmonic series of Nicolas Erasme. Now let's proceed to Giovanni di Casali, or Johannes di Casali. He was a friar in the Franciscan order, a natural philosopher and a theologian, author of works in theology and science, and the Papal Legate. About 1346, he wrote a treatise on the velocity of the motion of alteration, which was subsequently printed in the Venice in 1505. In it, he presented a graphical analysis of motion of accelerated bodies. His teaching in mathematics physics influenced scholars at the University of Padua, and it is believed may have ultimately influenced the similar ideas presented over 2 centuries by Galileo Galilei. Now that we're done with the mathematicians and philosophers under medieval period, let's proceed now to Renaissance period, presented by my co-presenter, Justin Quinones.
Good day, everyone. I'm Justin Quinones from Bachelor of Secondary Education, Math 2A. The assigned topic that I discuss today is Renaissance Mathematics and Renaissance Period. Renaissance, which began in Italy from 14th to 16th century, Renaissance, which means rebirth, a new way of thinking. A new way of thinking came to the fore, proposing a different form of training. The concept of zero and many advancement in algebra. Okay, let's proceed into the Renaissance mathematicians. First, Leonardo da Vinci was the typical Renaissance man with many talents, while we know of him as an artist. He also an engineer, scientist, and mathematician. His exploration of the world of proportionality in special mechanics preferred drawing as his primary tool to execute his study. His known work that employ mathematics is the Mona Lisa. Each applies the mathematical principle of perspective, golden ratio, and proportion in its composition in his painting. His painting Mona Lisa uses the golden ratio, has an approximate value of 1.618. In, in its structure, some say the beauty of picture as being its use of the golden ratio. Central elements of the composition use a golden rectangle and over the painting. The formula for solving golden ratio is a plus b over a multiplied by a over b is equals to 1.6118. Next, Albert Dürer. Dürer popularized his magic squares and inspired their study in the West. His work includes the first published 4x4 squares. The sum 34 can be found in the rows, columns, diagonals, each of the quadrants. The center, first square, the corner square. The number 15 and 14 appear in the middle of the bottom is indicating the date of the engraving 1514. Next mathematician is Johann Muller, also known as Regiomontanus. Is developed in Renaissance mathematics is trigonometry, the triangulis in 50s or in 1450s, first great book of trigonometry. Tabulae Directionum, a trigonometric treatise. He published De Triangulis Omnimodis, which the first textbook on trigonometry. It was treatise on plane and spherical trigonometry that included theorems and algebraic technique for solving geometric problems. And he calculated table of sines and tangents that were used by astronomers. Next, mathematician is Niccolò Fontana, also known as Tartaglia, and his developed in mathematics is formula for solving cubic equation complex numbers. Tartaglia is known for discovering the solution to the cubic equation, a cubic function of the form ax cubed plus bx squared plus cx plus d is equal to 0. Has three roots where it crosses the x-axis and two critical points where the curve changes direction. The formula for solving the cubic is known as the Cardano-Tartaglia formula. And lastly, Raphael Bombelli. His developed and Renaissance mathematics is imaginary numbers, was the person to write down the rules for addition and multiplication of complex. And Raphael Bombelli was an Italian mathematician who was a key figure in the development of imaginary numbers. He named the negative imaginary numbers to minus of minus, and positive imaginary numbers to plus of minus, to avoid confusion with regular radicals.
After the mathematically frugal age in which the Greeks lived, there came a millennium of relative stagnation. Discovery was few and sparse, and generally was concerned with pointless debates. Ad absurdum, how many angels can stand on the point of needle? A classic argument against the reasoning of the time. In the millennium that we call the Dark Ages, most Western mathematical knowledge was limited to translations by the Roman senator Boethius of the ancient Greeks. He had coined the quadrivium, the four subjects that he felt were necessary to study to understand the mind of God. These were arithmetic, geometry, astronomy, and music. Mathematics was used to explain nature, as was believed by Plato and the Pythagorean cults. The end of this stagnation was marked by newer investigations into ancient mathematics. Adelaide of Bath and Robert of Chester provided new translations of Euclid's Elements and a never-before-seen introduction of Al-Khwarizmi's Book of Algebra. This marked the spread of mathematics in Europe. The first great medieval mathematician was Leonardo of Pisa, also known as Fibonacci. He had traveled to the Almohad Kingdom in North Africa as a child, and there he learned and eventually spread to Europe the Hindu-Arabic numbers. Although anything Arabic was viewed with suspicion, these numerals were far less clunky than those of the Romans. One of his more famous ideas was that of a sequence, where every term equaled the sum of the previous two, the Fibonacci sequence. This came to him when he studied successive generations of rabbits. The ratio between successive terms approached, as was discovered, a very special number, the golden ratio. His mathematical knowledge was recorded in his Book of Calculation, or the Liber Abaci. Even hundreds of years before the likenesses of Newton and Leibniz, the fundamental ideas of calculus were being grappled with. 14th century calculator William Heytesbury attempted to measure instantaneous speed as, by the path that would be described by a body, if it were moved uniformly at the same degree of speed with which it moved in that given instant. That is, the tangent to a curve of displacement. Similarly, the distance covered due to uniform acceleration, later solved by integration, was solved as follows. A moving body uniformly acquiring or losing that increment of speed, will traverse in some given time a distance completely equal to that which it would traverse if it were moving continuously through the same time with the mean degree of speed. The dissemination of Greek text and knowledge from other parts of the world helped to bring the intellectual stagnation in Europe to a close. People began to observe the world directly and explain empiricism with mathematics. This could be said to be illuminating the West.
Geometry and art, the perfect blend, wouldn't you agree? Renaissance architects certainly thought so. They were master manipulators of geometrical shapes, using them to create harmonious proportions and balance within their designs. But it didn't stop there. These artists of the building world took their designs to another level with vibrant interior frescoes. Imagine the stunning impact of these colorful paintings, bringing life and depth to the otherwise plain walls. These frescoes, combined with the geometrical mastery, created an architectural symphony of form and color. The Renaissance architects were indeed masters of their craft, blending geometry and art with seamless perfection.